In this video, we're going to learn about Fischer esterification of carboxylic acid. So carboxylic acids react with alcohols to form carboxylic esters, usually just called simply esters. So what's the reaction for that? It's a carboxylic acid plus an alcohol reacts to form an ester and water. Now, notice we don't have a traditional arrow to the right for reacts to form. We've got our double-headed, our equilibrium arrow. I actually prefer it to be like this. The other one means resonance, but I'd prefer this double-headed arrow, but I don't always catch them every single time that I need to change them. But anyhow, let's look at our first example. We've got our favorite acetic acid, CH3COOH, plus ethanol. So ethanol is going to be HO for our alcohol, for our all, and then CH2CH3. So our two carbon alcohol, so the alcohol OH, we have drawn next to our acetic acid, and that's going to be important, but I don't want to get ahead of myself. It's reacting with an acid catalyst. So we've got H2SO4 over the arrow. We really need that acid catalyst to be over the arrow. And then it reacts to form ethyl acetate, CH3C double bonded to an O, and then bonded to an O, CH2CH3. So we've got the CH3C double bond O came from our carboxylic acid. And then we've got our OCH2CH3 came from our ethanol. So let's just kind of check all this out. Basically, our carboxylic acid, OH, got together with our alcohol hydrogen to form our water. Then if we look at acetic acid, the CH3C double bond O came over to be the CH3C double bond O of the ester, and the OCH2CH3 of the alcohol became the side chain, or OCH2CH3, put together there from ethanol to make ethyl acetate. So this is an example of a condensation reaction. Condensation is a general type of reaction that we will encounter often in biochemical systems. This specific type of condensation reaction that forms an ester is called Fischer esterification reaction, sometimes simply called esterification. It's not always called Fischer esterification. Esterification reactions always look like this. They always have a carboxylic acid plus an alcohol react to form an ester and water. And it does have an equilibrium arrow because the reaction is reversible. And it should have an acid catalyst over the arrow, usually like an H+, to show you that you have an acid catalyst or an H3O+, or it might be H2SO4 showing you it usually is done with a concentrated sulfuric acid. So something like that. General condensation reactions look like this. So what does it generally mean to have a condensation reaction? A general condensation reaction is like take an organic molecule plus an organic molecule and make a larger one and water. So that's what we're doing here, taking these two smaller organic molecules and making a bigger one with water. So let's look at some more examples of esterification here. So we've got our second favorite, benzoic acid, a benzene ring bonded to a C double bonded to an O with an OH. And then we've got methanol, which is just CH3OH. But we've got it written HOCH3. So it's written with its OH right next to benzoic acid's COOH. Okay, so we've got our carboxylic acid. Let's just kind of recognize that we have our carboxylic acid here reacting with an alcohol. We see an acid catalyst, H2SO4, above the arrow. And then sure enough, as we're expecting, we've made an ester. We made methyl benzoate. So a benzene ring bonded to a C, double bonded to an O, that's bonded to OCH3, and then also water. So we've got our two smaller organic molecules, our carboxylic acid and our alcohol, react to form our larger organic molecule, our ester, and water. And so it's really always the carboxylic acid's OH that gets together with the alcohol's H to make our water, to make our H2O or water. And then the new ester bond is the bond between the carbonyl C and the adjacent oxygen. That's our new kind of ester linkage, or our ester bond. I'm just going to label it new bond because I think that is sufficient. Okay, so that guy right there is our new bond. So our new bond is from the benzene ring. There's a C double bonded to an O. It's the bond from that C to the O in OCH3. Okay, so just to kind of review here, benzoic acid's benzene ring and C double bond O are the ones that carry over into the ester, benzene ring and the C double bond O. Methanol's OCH3 carries over into the ester. Methanol's H gets together with benzoic acid's OH to make water. Okay, how about another example? In this example, we've got CH3, CH2, C double bonded to O, and that C is bonded to an OH, so there's our carboxylic acid. Plus, we've got HO, CH2, CH2, CH3, so propanol, there's our alcohol. So we've got our carboxylic acid and our alcohol. There's H plus over an equilibrium arrow. So there's our acid catalyst, likely H2SO4, likely sulfuric acid, but anyway, there's our acid catalyst. So we're going to get our OH of our carboxylic acid together with our H of our alcohol to make some water. Then we're going to copy the carboxylic acid, CH3, CH2, bonded to a C, double bonded to an O. That's the first half of our ester. The other half is our alcohol's oxygen and everything that follows it. So our alcohol's oxygen followed by CH2, CH2, and CH3. So, where's our new bond? Right here between the C double bond OC and the adjacent oxygen. There's our new bond. And again, our OH of our carboxylic acid got together with our H of our alcohol to make our water. Okay, let's try another one. This has CH3, CH2, C double bonded to O, bonded to OH. So there's our carboxylic acid. Then we've got HO, CH2, 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 CH3. And we should, I prefer, just have an equilibrium arrow and an H plus over that equilibrium arrow. So let's just fix that way. And then we've got our OH of our carboxylic acid gets together with our hydrogen of our alcohol to make our water. And then we'll start copying our carboxylic acid, CH3, CH2, C double bonded to O, and then we'll copy our alcohol, our O, and then it's CH2, 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 CH3. And I'm just kind of squeezing it on my screen like that. So our new bond here is again between the carbonyl C double bond OC and the adjacent oxygen. And then we've made our new ester linkage, or our new ester bond. So again, this Fischer esterification is a specific type of condensation reaction. We're taking two small molecules, our carboxylic acid and our alcohol. We're making an ester, and water. So our ester is our larger organic molecule plus water.